Hey everyone, so we've got our final lesson today on our systems of equations. Today we're going to talk about systems of equations from context. So that basically means we are going to be writing our own systems of equations given a word problem. The first thing we're going to talk about are just the 6 steps. Now a couple of these are going to seem self-explanatory to you, but I just want to make sure that we are clear on the order that we need to go through in order to get to the answer that we're looking for. The first thing we need to determine what we are trying to find. What are we solving for? Usually it's going to be the last line in our question that we've been given. Sometimes it could be the very first thing. Find this given this information. For your assignment today, I think they should all be the last sentence. We'll talk through a couple of examples on how to know where it is. The next thing is to set up your terms. In other words, we need to define those variables that we are trying to solve for with our systems of equations. Once we have variables, we can set up equations. So we're going to use our variables that we have made to make 2 equations. Remember that a system of equations always has at least 2 equations. For your assignment today, it will only be 2. We won't be dealing with more than that. The next thing can be a little bit tricky. You want to identify and use the method that makes the most sense. So you want to ask yourself, is it easier to use substitution or elimination? Once you've figured out which method you're going to use, you're either going to plug in your expression or you're going to try and cancel out. So we do our first step, solve either with substitution or elimination. And then our final step is our same final step that we always have, is to plug in and solve the final variable. Because we have 2 equations, there are going to be 2 variables that we have to solve for. So let's take a look at a couple of examples. Our first example is Jaden, and she has $2.95 worth of dimes and quarters. She has 2 more quarters than dimes. Determine the number of dimes and the number of quarters that Jaden has. All right, well, back to our steps of solving this. We said the first step is to figure out what we're trying to find. And the reason why I call it determine is because our sentence starts off with the word determine. When we're talking about systems of equations or we're trying to solve for multiple variables, they always want to use the word determine, find, solve. Those are all going to be the same thing. So we need to determine the number of dimes and the number of quarters. So on our blanks down here, I'm just going to write number of dimes and the number of quarters, because those are the 2 things we are trying to find. Now our second step tells us that we need to set up our variables, define what our variables are going to be. As I said, our things that we are trying to solve for are going to be the variables that we make up. I like to pick just the first letter of each part that I'm trying to find. So we'll have D for dimes and Q for quarters. The next step can be a little bit tricky though, and there's something I need to point out before we get there. Remember that we're not just talking about 2 different terms, dimes, quarters. We're specifically talking about money. And dimes and quarters have 2 different values for price. We know that dimes are 10 cents and that quarters are 25 cents. So when we look through these 2 sentences, we want to make sure that we are aware of that when we set up our 2 equations. Let's take a look at this first sentence here. Jaden has $2.95 worth of dimes and quarters. Well, it's important to note $2.95 worth. That means that this is my total amount. So I know that I have $2.95 equal to something else. That something else is my total amount of dimes and quarters. So I have my amount of dimes and my amount of quarters. But remember, it's not just the amount of dimes plus the amount of quarters, it's the price of the dimes and the price of the quarters. So we've set up our first equation. Let's move on to looking at the second sentence. She has more quarters than dimes. She has 2 more quarters than dimes. So the important thing to note here is this more quarters than dimes. I don't care how many more right now. Specifically, I know there are more quarters than there are dimes. So my next equation is going to be Q equals my dimes plus how many more quarters I have. Well, this first part tells me I have 2 more quarters than dimes. So dimes plus 2 will give me my total amount of quarters. So now I have 2 equations set up. Now I need to figure out, is it going to be easier for me to use substitution or is it going to be easier to use elimination? Well, for this problem, you can see that I have already solved for Q. Q is already by itself here and has this D plus 2 as its equal. That means that I'm going to take this expression and plug it in for Q. In other words, it's easiest to use substitution. So let's go ahead and plug that in. 10 cents on the dime plus 25 cents of my expression for quarters, T plus 2 equals $2.95. Well, I need to distribute this 25 to each term here in my parentheses. So I get 10 cents dimes plus 25 cent dimes plus 25 times 2. 2 quarters is 50 cents. And that's $2.95. I can subtract this 50 cents from both sides to give me $2.45. And I can combine my like terms, 10 cent dimes, 25 cents dimes. That will give me 35 cents dimes. Now, I need to figure out what dimes is on its own. A quick thing to note is since these are being multiplied, I'm going to divide both sides by 0.35. Now, if I take my dimes equal 245 divided by 0.35, is my amount that I get when I divide this going to be bigger or smaller than 245? Well, I hope you said that it would be bigger because when I multiply by a decimal, the number I'm going to get is actually going to be larger. If we go back to this expression here, I am saying that when I take a small decimal and multiply it by a number, I get 245. In other words, I'm taking just a small portion of a large number to get 245. D has to be bigger in order for it to be equal. So if you punch this into your calculator, you'll get that the amount of dimes is 7. So I'll put that in our box here. We have 7 dimes. Now that I've solved for dimes, I can take and plug it into my second equation, completing our final step, and solve for our amount of quarters. Quarters equals 7 plus 2, so we have a total of 9 quarters. Now, if you wanted to double check and make sure that this was right, you can plug it back into that top equation there, and we'd have 10 cents times 7 plus 25 cents times 9, and we hopefully will get that to equal $2.95. Well, this would be 70 cents plus 25 times 9. Well, I know that in $2 there are 8 quarters, so this would be 1 quarter more for $2.25. Combining those together, we do in fact get $2.95, telling me that we have done that problem correctly. We'll go through one more example, and then I will have gone through everything that we need to talk about for these systems of equations. All right, so we are on to our last example problem today, and we'll just read through it first so that we know what we're dealing with. Grace works as a salesperson at an electronics store and sells phones and phone accessories, and makes a fixed commission for each phone sale and a different fixed commission for each accessory sale. Yesterday, Grace sold 18 phones and 21 accessories and made a total commission of $204. Today, she sold 6 phones and 14 accessories and made a total commission of $82. Determine the price of each phone and the price of each accessory. Well, the first thing we want to do is figure out what we are trying to solve for. There's a lot of words here. And the first thing we need to look for is that word determine. And again, it's in our last sentence. Determine the price of each phone and the price of each accessory. So we have the price of a phone and the price of the accessory. When we're talking about the price, we're specifically looking at the price of the commission, not the total amount that a customer would buy the phone or the accessory for. So we know we're trying to find the phone and the accessory. And that's in dollars, so I'll note that there. Now, the next thing is to figure out if those are going to be my things that I'm trying to find, I should probably set up what their variables are going to be. Again, I'm just going to use the first letter of each item. So we'll have P for phone and A for accessories. The next step, I need to be able to write some equations. So now we have to go back and reread some of our problem. Well, you'll notice that this first long sentence doesn't actually tell us anything about the problem. It tells us that Grace works at an electronics store and she sells phone accessories and makes a commission that's different for the sale of the phone and the sale of an accessory. However, the next two sentences are important for us. We know that Grace sold 18 phones and 21 accessories to make a total commission of $204. Well, this total commission part tells me that that is going to be all on its own, 204. And to make up that 204, we have the price of 18 phones and the price of 21 accessories. All right, so we have one equation down, one more to go. We found out that she also sold 6 phones and 14 accessories to make a total commission of $82. So again, we have $82 and our phone cost plus 6 and 14 accessories. So now we have our second equation set up. So we've set up our equations, we know our variables and what we're trying to find. Our next step is to figure out, are we going to use substitution or elimination? Well, for this problem, we are going to want to use elimination. Remember, when we want to use substitution, I would have already had one of these terms isolated or on its own. I would have A equals or P equals, and that would be easy for me to use substitution. However, for this one, I'm going to use elimination because I noticed that 6 can be multiplied by a number and go into 18. So that means it's going to be easiest for me to eliminate one of my variables, solve for the other, and then plug that in. So let's go ahead and do that. We already said that I can multiply this second equation by 3 to get those p's to be equal. But remember, I don't like to subtract my equations from each other. I like to add them together. It makes it a little bit easier. So I'm going to multiply by a -3 to make the signs on p different. Multiplying each part of my equation by -3, I would get -18p. 14 times -3 would give me a -42a. And 82 times -3 would give me a -246. I'm going to put a line through this equation because I don't need it anymore right now, but I might want to use it later when I have to solve for p.
So now I'm going to add this top and the bottom equation at each point. Well, we did this specifically so that my phones would cancel out. My accessories become a negative 21 when I take 21 plus a negative 42. And then if I take 204 plus a negative 246, I will get a negative 42. Well, we specifically want this to be 0 so that it goes away. 0 does not change my equation at all, so it does not matter. And now I can divide by negative 21 to get a all by itself. So a equals negative 42 divided by negative 21 would give me a positive 2. Specifically dollars, so we know that Grace is going to make $2 for each accessory that she sells. Now that I've solved for A, I can plug this back into any equation I have on top. And this was why I wanted to make sure that I could still read my second equation. I'm going to plug it into that one because all of my coefficients are smaller than any of my other equations, and they're all positive. So it checks both of those boxes. I'm going to plug A in to this equation. So we have 6 phones plus 14 times $2 equals $82. So I'll get my 6 phones plus 14 times 2 is 28 equals 82. To get the phones by themselves, we minus 28 from both sides. We get 6 phones. We'll give Grace a total of $54. But I want to know for just one phone, so I divide both sides by 6. And we get that the phones equal $9. So phones, $9. And we've solved for the Grace's commission problem that she was having. Now, if we wanted to double check this, we can plug these numbers into any of our equations that we've solved for. Let's go ahead and plug it into the first equation we found. So if I have 18 times P, which was 9, plus 21 times 2, which was A, and that should give me $204 for her first day's total. Well, 18 times 9 is going to give me 162. 21 times 2, that would be 42. And that should equal 204. Well, adding those two together, I know 2 and 2 is 4. And 160 plus 40 would indeed be 200. So 204 equals 204. That all checks out. We are good to go. We have solved Grace's problem here. Now, this is our final lesson for systems of equations. The next few things we are going to look at doing are going to be some more topics that will get you ready for next year, as well as looking back on this last school year. I know today's lesson is a little bit tougher than our last few lessons, so if you have any questions, please send me a message, send me an email, ask for help. I'm more than happy to help. See you next time.